two, one. Hi everyone, welcome to our YouTube channel, Becoming a ROS Developer, here at The Construct. My name is Rodrigo, and today we have one of our students, Omer, who is doing two presentations for two different courses, actually. So this will be a little bit longer than usual because it's two of them. He took our courses, ROS Basics, in 5 days, as well as ROS Navigation in 5 days. And he's going to show us how he did the final project of these courses on a real robot. And he's going to show us first the basics of ROS, which is what we teach in our ROS Basics course. Talks about topics, actions, and services. And then he's going to also present what he did for navigation to make an robot autonomously navigate. So hi, Omer, how are you?
Fine. Thank you for the introduction.
No problem. So yes, whenever you're ready, you can start sharing your screen and then just show us what you've done with your project.
Okay. I think I might just start with navigation because I think it will take the most time.
Great.
So let's start here. First, we will run Arvis. Then I'm going to start mapping.
Okay. So what do you mean by mapping?
Means I'm going to create a map of the environment of the robot.
Okay.
Maybe we move the robot a little bit here, so it can get a better known of the environment it will work in.
I see.
You can see here the mapping starts already on the Arvis.
Oh, I see. I see. Cool.
Gonna, just gonna build the screen here and that here. Okay. So we are going to move the robot. No, no, no. I think I hit a wall.
Well, it it could be an issue, but that would be visible in the map. So I think you're okay. So we see it completing now, sort of.
Yes, you can see the map now completing as the robot moves and collecting data from the laser and odometry.
Mm-hmm. So I think it's finished, no?
Yes, I'm just going to go there, just that spot
Mm-hmm.
for so now it's finished. So I'm going to run the map saver so I can save the map I just created.
All right.
I think I just made it. Okay, let me see just a bit. It was map saver, map server,
I think you can
or
auto tab, auto complete, and it might be map server. So yeah, map server, then space and map saver without the pi.
yes. So we are supposed to see the map at the main directory here. I will open it now. This is, I
Right.
think, this is the files we need.
Right.
So I just going to move them here. Uh, let's see first what map my map. Okay. So I'm going to delete the old ones.
What for?
I'm going to name them the same name,
Oh, I see.
basically, because
I get it.
name the other one. Now I'm going to take both of them to here. Now I'm going. I just created that folder so I can store my maps,
I
the
see.
maps I created. So after we finished the mapping process, we no longer need the Gmapping package launched.
Right.
We are just going to shut it down. I think it's here. I just shut down Arvis by,
By accident.
yes.
A recommendation for that, you can double click on the terminal tabs and name them.
Oh,
That's just a nice feature we have.
I will do it, but due to the time now.
No, no, I understand. Yeah.
But I'll take your advice. So, now we are going to start navigation directly. I think we don't
Okay.
have to show localization and path planning as they are all will be represented in the navigation.
All right. Yes, I agree.
Here we can find. Here you can find the navigation package, and we are going to the file we are going to launch is coordinates.launch.
Mm-hmm.
So let's start.
So you said this launches localization, path planning. Is there anything else?
No, I say that the path planning process and navigation
Uh-huh.
will be shown all in the during the navigation.
Okay.
They
Yes, yes.
start with. Oh, think I think it's due to the
So it says it's looked for a map called map.pgm, right?
here
Maps map pgm.
map.pgm.
I thought I just read that you called it as my map.
Yes, I do. I think I go to provide map.
Maps. Yeah. So
So I name it here my map. Okay, but maybe the error in here. I
oh yes, definitely. Yes, yes. You'll have to rename that as well.
I think
Yeah, that's the issue. This one is just numbers. The PGM.
yes.
Well,
So
it's a
I'm
image, I
going to
guess.
start it again. Now it starts. Yes, very good. I think I'm going now to we need to yes, there is the particles
Uh huh.
we're looking for. Each one of these particles, those particles represent uh, يعني a position of the robot, a probability
Right.
in which the robot may be. So we are going to move the robot. In order to localize the robot, we should move it a little bit so
Mm.
it can gather data and have a better understanding of its location.
Mm-hmm.
So as we rotate the robot, you can see the particles go near.
Right. They start to converge.
Yes, start to converge. So as I gather the data, so basically what is done here is the robot takes the data from the odometry and the laser. It updates the position of each particle,
Mm-hmm.
and then it do the process again and again until they all like they all at the same place or the same
Right.
point.
But it looks like it's converging since this is a really symmetrical map.
Yes,
It
it
looks
just
like it's
making.
converging in another spot. So, yes, this is a way to do it to move it around. But let's see if what can happen if you directly send it a 2D post estimate from Arvis,
I will show you
right? Because right now it's not exactly in this spot. So let's see if we can force it.
2D pose estimate.
Yes, the 2D post estimate.
So it's here in the map. I think the map rotation is it's not right.
Yeah,
Okay,
so that's what I'm
we are
saying. So if you
going to use the map, the pose estimation. I think it's just may take a little time, or
maybe let's see.
maybe
Oh,
this is odd. I
well, that should have updated already.
I don't know why. Just there. Maybe also the robot is not moving. As I am moving it with the teleop, I think it's not moving.
Did it
You
stop
can see
moving?
the yes, you can see here I'm increasing the linear speed, but I think we have a connection
Huh.
error or lag here. Maybe I
Maybe,
can
yeah,
I
maybe
can
try killing. So that seemed to happen once you launched the navigation, maybe? So
uh,
let's try and kill it and try moving
navigation.
again. Yeah, yeah.
Maybe
Maybe it's
I'll
getting
try that.
overloaded for some reason, but because you were just moving it a second ago. So
Now the navigation package starts. Start working.
yeah, yeah. So that means you're connected. So I don't know why you couldn't move it.
So we're going to use it again, hoping it will work.
That
Why
is
it is
very strange. That should be. Um,
this is never happens.
I know. So this is a service, right? The 2D post estimate that also comes in a service. So let's see that it's
Yes.
available. So in a new terminal, you could do look for AMCL post estimate or something like that in the raw service list.
Sure, I will do that. Oh, service. Just yes. Yes.
So here
So
we should have like an AMCL at the
AMCL
top, probably.
sales get loggers set parameters. I think we don't have
It looks like for some reason, maybe.
it, I think.
Hmm.
I can find it, but
No, no, I mean, so what you could do
this
also
is
is, you
so
know,
this is strange. I know.
you can try and also reset the localization. There is an, I think the global localization service. You can call
Yeah.
it, and it'll disperse the particles again. Uh,
Okay.
so maybe that's an option, but yeah, if we
I
can't localize
think
the robot,
maybe I'm going to just start the kill the mapping. Maybe I'm going to just start the localization package for now. I give it a try.
that's a good idea. Yes.
So MCL here. I'm going to start it directly. You can see the map server and the MCL running.
Mm. And also kill Arvis and launch it again, because I'm
Yeah.
still puzzled by the button not working. So maybe by restarting Arvis itself.
so we can see. Yes. We should have seen the particles by now. I think this is strange.
That's Arvis.
That's Arvis, but I don't see the
Yeah, the
particles.
particles. Maybe try forcing the 2D pose. Again, try and clicking that. And just putting it in the map somewhere. Huh.
It's also not working here.
Well, yeah, but I think it's because the AMCL just hasn't run yet.
It's running. I
Oh, yeah, I see it.
just I see ignoring initial pose in frame.
Yeah, yeah, yeah. Initial
Pose
poses must be in the global frame map.
in the global frame map.
You are setting it in map, right? The global frame in the Arvis right now is map.
Yes, I did,
Hmm.
but I don't know from this never
Oh, in
happens.
frame autumn.
In
It's as if it
ignoring.
was, so it's saying ignoring initial post in frame autumn. It's as if, oh, yes,
Yeah,
this
I just
fixed
will
frame.
change the configuration here.
No, no, no. I know the whole problem now. So, yes, map. Yes, yes, yes.
Yes, maybe.
So now here, you might not see the poster. Oh, because it's unchecked. So if you check the pose array on the left, I think you'll see them.
Now we are going
Yeah,
to see
yeah.
them.
And now that button will
Well,
work.
I hope so. Yeah, it does.
That was the reason. So the reason why it was happening is because in the RVIS configuration, we had
We
set
are
the initial pose with the wrong frame, so that's why it wasn't changing. We just didn't see it. All right, cool.
so it basically in the first time we were setting it to map as all this Arvis configuration. I name it. I use it all the time.
Mm-hmm.
So when I shut down Arvis and restart it again, I forgot to
Right, to set it. Yeah, don't worry, don't
set
worry.
it.
So I think now that it's actually better
Yeah, we
localized, you can, just a tip, I think the best way of localizing, it's rotating to one way, just on its own like axis. Just rotate it to your right and then rotate it to your left, and you'll see. I think it does a good job, and it might
yeah,
be better at not losing itself, right? So let's see.
right. So I'll do that now.
There we go. That looks much better.
Out the left. I think this is
I think
good.
that's perfect. Yes, I
Yeah,
think so. You
maybe we
can,
are now.
if you kill this, you'll lose this, right? So you can either do it again with the whole main launch that you had, or
Lunch.
launch navigation independently.
Yeah.
So I think,
Now it starts. I think. Subscribe to Topic Laser. Let's just take its time.
I think I
Okay.
might have seen that you also launched AMCL in this terminal, which would mean
Yes,
it killed.
it killed the previous
Let's
one,
see in the other
maybe.
terminal.
Yeah, it
Yes.
did.
So you're gonna have to
Uh,
redo it here,
do
yeah, because now you don't have localization
do
anywhere because it dies here too.
okay. But I think the particles
They're
are
still going. All
old.
right, then let's try it. Let's see what happens. Then maybe it didn't die on the other side. So if this works and everything's running, you should be able to launch a navigation goal, and it should go there.
Yeah, I'll do that right now.
Yeah, try it through Arvis.
So here you can see the local cost map and the global one.
Uh huh.
Now we are going to start our service. Let's just move it to the corner two, corner one. This is corner one.
What are these coordinates?
So in the project, they told us to store the position of three locations on the map. Corner one here near the construct logo, the pedestrian, and corner two.
Uh huh.
We basically move it to a text file, and then we save it in a text file. Then we extracted it and use it and send it as a goal to the robot.
Okay.
So
So I think you mean to do raw service call.
yeah, my service is name is get coordinates.
Okay, and you've already launched it, I assume.
Yes.
Okay.
So we are going to give it corner one. You
So
can see
it's
now
yeah. Go ahead.
it says navigation successful, true message. Okay, that's mean the goal is sent to our navigation package.
Okay.
You can see now the robot moves. This
Yes.
is
Oh, but
the
look,
the
it's
goal.
trying to go to a place that doesn't exist, and this
Yeah,
works.
it's outside the map, just like I said. The map I used
It's different.
is different. So maybe we are by changing the map, we are changing the
The coordinates for sure. Yes.
yeah
Try one of the other two. See if they're in the
yeah. I'll just do that.
because right now we see the robot rotating, trying to find a path towards the point you set. So here, this one is
This
inside,
one it's inside the map. Yes,
but you can see again that the the global cost map might be on the way. You see?
what
So, oh no, you can see it. It's trying to, but it might be too by the corner for the planner to find a solution.
I think so.
So one
So
idea is just do a 2D nav goal here, right next, yeah, and just send it somewhere. Okay, it
I
should
think
be going there
nice.
now.
Yeah, I think the problem here is
It's going. I think it's moving.
yeah, it's moving, but the problem here I faced is that when I use the telehub, it just got stuck. So I think when I
Oh yes, yes, it was probably the tell. Oh, there we go. Look at this.
yeah,
Nice.
so now it reached the goal.
Oh, that's
We
really well
can
localized too.
sorry, we can do now. like see the use our service again
Uh huh.
as we solve the issue. Let's tell it to go to the pedestrian. It will go, but the location is different.
Yes, and it might not
Uh,
get there precisely, and you can tune
yeah,
this.
I can tune this, but I can do this now, but due to the time, so
No, I understand. Yes.
we
But
have
you do
another.
understand why the coordinates are different, right? So
Yeah,
when you start mapping in the simulation, that's where the 0, 0, 0 of the map begins, and you
yeah.
started this in another scenario. So that's why
So
you will need to save the coordinates again and then send it. But this one worked. It's obviously not the same one, but the idea is the same.
yeah, we have
Could you try and do like a little bit of a difficult goal, like sort of like on the other side, to see if it kind of can,
here,
yeah, like
like here.
detect the obstacles and move around them
Okay.
somehow. Here we go. So it's looking at the cost maps and
Just the local cost map just gets stuck sometimes, so I'm
right.
like going to uncheck them and check
Oh
them
yeah,
again.
yeah.
So just for knowing,
Mm-hmm.
you can see it now moving you the goal.
Right. And if I was to put an obstacle in the middle of the already made path, the local
Like,
cost map would catch it and replan
yeah,
around it. All right.
that is the purpose of the local cost map. It it basically detects any change in the map, like if something new, obstacle inserted in the map that's not present in the static map.
Mm-hmm.
Its job is to detect it so that the local planner will find a way to avoid it.
All right.
Yeah, you can see that the robot reaches position.
Mm-hmm.
Maybe now we are going to explain a little bit of the code I made.
I have a suggestion for you, Omer. Just because of the time,
Yeah,
and because you'll see, I have a lot of good
17.
comments on this. I would recommend something. I recommend now, since we see your project in navigation, we've seen it autonomously navigate using this coordinate you made. We can we see this and we understand it. Now we can
Yeah,
move on to, for example, the
the ROS
main
basics.
the ROS Basics main program, which you can explain and we can see it in this last 10 and minutes, and then we can go ahead and explain a little bit.
Yeah, I think this is a good idea.
Yeah, because this is the first time again, guys, that we do a double presentation, and uh, we're trying this new thing. So yes, let's go and try that. So
I hope it
while this is
doesn't.
loading, let me just tell you about the navigation that you set up. First, I mean, really nice, really clear, really shows that you understand what was going on. And so the two things that I would talk about is the realization that a lot of the inner workings of navigation depends on the map you have loaded, and this map changes. So that's why we saw those differences, for
Yeah,
example, in your program. Then uh, I like to see that you were able to launch things independently, to figure out, oh, maybe I'll just launch the localization first. Maybe then I can launch it independently. That shows that first you have practiced a lot, and that you
yeah.
have an ability to debug things effectively. So that was really nice to see. And
Thank you.
um, just one comment I would recommend is to try to avoid renaming files and dragging by hand um, files like you
Bye.
did with the map. I know it's tempting, but it can lead you to further errors that you'd spend a lot of unnecessary time trying to debug. For example, you found that really quickly that the YALM was looking for another file name. But you could do this from directly from a launch file that you create, uh, properly. You can set arguments that you can control this a lot more easier. So
Yes.
that would be my other suggestion. But other than
I
that, it's
just
really good project, man.
Thank you. I just choose the easiest way.
Yes, yes. But it can get out of hand quickly. All right. So here you have opened the other one. We got 14 minutes. We got time.
I hope we manage to see it working.
Yes, yes, that's the main point of this, that we can see that you have spent the time to actually learn these concepts. So great work on that autonomous navigation. Now
Thank you.
Omar is going to show us for the other course, the ROS Basics, in 5 days, in which he's going to show us the program he did, and you can explain it yourself, Omar.
Yeah, I will start now. First, we are going to use Teliab just to move the robot a little bit. I'm going to have our screen here. Okay. So we are going to use nice. It's just loading, I think. Not started yet.
The robot, you mean?
No. I see
Oh,
the
that
web
it's
shell here
loading.
is loading.
Oh, I
I
think
I
that's
thought it might
no. You
might
you can already
be
move it, like, but you
yeah,
can open a new tab on this one that is opened. So in that plus, right next to the 720, yeah, I'm pretty sure you can continue your.
yeah.
It's just a kind of the graphical interface. I think stayed like that.
So we are going to now just decrease the speed. Yeah. W and X. Think I'm just lowering the speed.
Mm-hmm.
So I think the error here is as we moved the robot uh, too fast at the first, we got like
Oh,
uh, shutdown request.
yeah. So you can
Maybe
just Control C and up and enter.
yeah. So first lowering the speed. So now it's fine.
So you're moving it to a location for what? To start
It's
your mission.
just like a start point.
Okay.
Start the package. I don't want it to be near this obstacles here.
Right.
It might thought that this is a wall and it's not.
Okay. I
So
understand.
I really don't want that to happen as we don't have time.
So are you able to just run it directly, or you have to change some things, and that's why you're opening the ID?
I'm just going to
Double check.
double check for the name. I think I may forgot it.
I don't know why it's kind of loading
It's
forever
taking
here for you.
yeah. That's bad.
Try closing this, because no, look, it seemed like kind of stabilized. So yeah, try this. You're not an incognito window by any chance?
No, I don't. It is not running here.
Well, we can leave it loading, and we can figure out the name just by doing ROS launch.
Like ROS launch.
The name of the package is probably turtle. I don't know. So you can do an ls Catkin workspace src. No, you
Done.
can do
I think
ls,
yeah.
then or that, yes.
Now we are in the Catkin. So
Well, you gotta put
source
it in the source, yeah.
project.
It'll be
Okay.
project, and then it's gonna be a main.launch or something like that.
I just want to see the scan test. Now we having it. I'm going to go into the launch. Okay, it's project.launch. We got the name now, so I think we will return. Now we are going to launch our project.
So this should autocomplete
Yeah, I just prefer to
to type it completely. Okay.
yeah. So you are going to see here first. I just have done some of the rospy.log info
Uh-huh.
just to see the process going.
Yeah.
You may see here that the right distance is the lesser one here. It's the shortest distance here.
Uh-huh.
Okay.
Uh-huh. And we can see it. It's already
Yeah.
starting its loop.
You can see here. I just name them by case. So we are here in the second case, the case where the right distance is the shortest one.
Uh-huh.
You can see here while the find wall service started and the robot first starts to rotate until the forward is in position.
Uh-huh.
After we got the forward is in position, I mean here the readings of the front laser at 360.
Hmm. Okay.
Okay, so it start now to moving forward towards the wall
Right.
and trying to reach its ready point. Its ready point here, it's mean uh, they wrote in the description for the project to move the robot until the readings at the 270
Right. Which is
degree is
the left side or the right side?
at the right side
Right.
is 0.3 like we see above.
Uh-huh.
I think you can see now that we can see here the action.
Right, which is
Okay,
the third part. The action is
yeah.
doing what?
The action here is recording the total distance
That the robot has
the robot
traveled.
that the robot has traveled. You can see. I just wanted to stop it a bit.
Uh-huh.
Okay,
Yeah, I see.
you can see it says moved so far is 3.
Right.
I just print the laser reading here, the front laser reading, so I can just know when the robot is going near a wall
Right,
or
right, right.
or so. But I think it's just make trouble, as we can see the action. Uh,
Yeah, right underneath, right. It's outputting the distance.
yeah, maybe you can do something.
Yeah, we can see right there.
Yeah,
Okay, yeah.
you can see
Very total.
yeah. It also prints here the distance from home. Okay.
Mm-hmm.
I set it when the distance from home is less than zero point 0.3. The robot should stop. Now you see we are going near
Near the beginning.
yeah, near the beginning point we started in. So the action service should stop now and return to us a list of the coordinates.
Oh, that's all the
Uh,
coordinates.
yeah, that's all the coordinates the robot moves in.
Oh, and the robot keeps going. So you return the
Yeah,
action, and then you can just keep going on forever.
yeah, I just set it like that.
Right, right, right.
I just figure out that the robot does not need to stop.
No, not at all.
We just need to know that the robot completed a full lap.
Mm-hmm. You could even
Okay.
call the action again if you wanted, right? Because the
Yeah.
server is running, you can just call the action, and it will do this eventually
Yeah.
for the lab.
I think the bad here. I should have removed the front laser readings. That is, I think it's kind of distracting.
Right. Well, that's for
Uh,
you though. That means you that means people when there's a lot of prints, that means you've spent a lot of time with it, and you're getting information that you want. And yes, this is like
yeah.
a cleanup thing, but it's nice to see that you use the log and do that. Um, so could you please summarize? Because I think uh, this has been a great presentation. We've covered both projects, except so I I hope you're okay with this, to not go in detail through the code now, because we have seen that you've done both projects really nice and successfully. So just to summarize, could you tell us then the three parts that you did in this section, in this project?
Okay. So the first part, I just started the fall forward
Mm-hmm.
uh, program. The main idea is that I move the robot like we just see near a wall or something.
Yeah.
Uh, so it can. So when I start the program, the robot should move near the wall, like we see now. Um,
And that's done
and
through what?
uh, basically, we are getting the laser readings, and based on them, like the front one and the right one, and based on them, we going to send a twist messages to the robot through a topic, CMD val.
All right, right, right.
Okay. So we can, like you see, when it's really near to the wall, you are going to see it moving a little bit to the left, and when the front laser faces the wall less than in a distance less than zero point 0.4,
I see.
you gonna see it turning really fast to avoid colliding with it.
Right.
So that is the first part idea. The second part is using a find wall service. So the basic idea is that I can find the nearest wall
Mm-hmm.
near the robot. So what it did here is the first we get also the laser readings from the front, left, and right. Then based on those readings, we are going to see what is the smallest one,
Mm-hmm.
uh, and based on that, the robot will decide which wall follow, as we see,
And those were the cases
so
you
now.
talked about.
Yeah, it's basically three cases. The first case, like the left is the shortest. The second case, the right
Right.
is the shortest. The third case, we are talking about the front here. In case the front is the
The
shortest.
shortest.
Yeah. So after we finished that part, the action, we are going to the third part, the action part. I think the real robot
Oh, we
session is
lost it.
finished.
Don't worry,
Okay.
don't worry. We've seen it. We saw like 7 laps. Um. So actually, do you mind stopping sharing your screen now so we can kind of look at our faces here while you finish
Okay.
up this explanation? Okay, great.
Okay. So the third part we are talking about the action.
Mm-hmm.
The action here is responsible for recording the start position the robot was in. Okay. Then it start calculating the distance based on an equation. I put it in the code. Okay. And the Euler angles, it's just kind of like the root of x square plus y square and so on
Right, to get the linear
to
distance.
get
Yeah.
the linear distance. Uh, so the action server starts to calculate the total distance from home and also the distance from home right now. Yeah, like it calculates two things. First thing, it calculates the distance from home, which is increasing and decreasing
Based on yeah.
based on the robot location. And the second thing, it calculates the total distance traveled
And it has to
by
be
the
larger
robot.
than something.
Yeah, we saw it. It was 5 at the end of the lab, and by that we just finished the third part and the ROS Basics project. Uh, it's just the basic idea.
Right, right. And that last part, you had to do those two conditions. Why is that? Because in the beginning it could have seen it as in the vicinity and returned the action.
What?
So you said you have two conditions for that action. One is to look at the distance traveled, and one is to look at the vicinity for where it started. Why not just have that
Yeah.
one?
So actually, they wrote in the project description
Mm-hmm.
that they wanted to store the total distance. It's just like the feedback.
Mm-hmm.
Okay, we have I can show you a message here that I did for that.
Sure.
So maybe I going to share the screen a little bit.
Mm-hmm.
Okay. So you can see the code here. We just are going to the main point. So the self.feedback current total, like
All right,
the
I see. Uh-huh.
you see the feedback is the current total, okay, and the result is
The
the
whole
list of
list.
odoms, yeah, the whole list.
Okay.
So the main reason we are doing that, we calculating the distance from home is that to know that the robot completed a lab, a full lab, so that we can know like if you want to stop it, if you want to do something
Right, right, right. I understand.
like that.
Cause yeah, yeah, you need both. Right, right. Okay, great. And let me see what else I um, wrote here. Oh no, just that I liked that you also understood the um, the concept of the servers, like the action server that you can. It doesn't mean like we didn't write the description of that project to mean that that will end the program and that's what actions are for. No, it's just an extra tool in your toolkit that you can use as opposed to the service server
Yeah,
because in the service server you have to wait for the return, so you wouldn't be able to see the feedback or something like that.
yeah.
All right, Omer. I have nothing else to say except congratulations. Really
Thank
impressive
you.
to have done these two projects and present them at once. Uh, we thought it was worth it to try, and I think it was really good because now we saw that you have the autonomous navigation capabilities to do autonomous navigation with the robot, and then a program that utilizes everything from the basics. So even then, in this little application, these two things, you could think of so many different things you could do with a robot. For example, use navigation like you have to send it to different general spots of a house, for example, and then do a certain program like the follow the wall, or if you have a Roomba, clean the room, or if you have follow the line, whatever you want. But now you can see how you can grab sort of pieces from the ROS toolkit and shove it together so you have a
Yeah,
really good behavior. And I think
yeah.
that was really well exemplified by you today. So congratulations, Omar.
Thank you.
Uh,
I'm very happy with that presentation, and I'm very satisfied with the result. Very happy also to see the result of my project, and that's it. It worked.
Yeah, that was really impressive because and you
Yeah,
knew how to manage everything right in the spot. So that again, that shows that you have actually learned through these two courses, which is our objective, while by offering the certificate with the presentation to make sure the students have done what you've done here. Uh,
yeah, of course.
So again, congratulations, Omar, and to
Thank
whoever
you.
else that is watching, you can definitely learn what Omar learned here today, and apply it to whatever projects you want, and by doing the courses that were shown today. Again, these courses are ROS Basics in 5 days and ROS Navigation in 5 days. So try it out, you guys. Learn here like Omar did, and yeah, again, Omar, congratulations, and we'll see you again next time for our next presentations, hopefully. So,
I hope so.
all right.
Thank
So,
you.
thank you. That's it from the Becoming a ROS Developer. So, you guys, we'll see you in the next video. Okay, bye bye.